everyone, welcome to this explainer. I am so glad you're joining me today. As a senior software engineer, there's one thing I see tripping up developers over and over again, both new and experienced, and that's how they handle application configuration. So today, I'm going to walk you through exactly how and why we move hard-coded properties into configuration files in Spring Boot. We're basically going to take those brittle, hard-to-maintain variables and turn them into robust, environment-agnostic code. Okay, let's dive right into this. Here's our roadmap for today. We'll start by talking about why you need to stop hard-coding configs, then setting up application properties, the magic of duration, binding to typed records, enabling configuration scanning, and finally, a quick summary and next steps. Let's get right into it. Part 1. Stop hard-coding your configs. So you're building a client, right? And immediately you hit this incredibly boring but absolutely crucial question: where exactly should your base URL and your timeouts live? I know, when you're deep in the code and just trying to get things working, it is so tempting to just hard-code those values right there inside your bean. But trust me on this one, you have to resist that urge. And here is exactly why. Hard-coded URLs and timeouts are literally the #1 thing reviewers are going to flag in your Spring code. Why? Because they completely wreck your environment consistency. Think about it. If you hard-code a timeout, you are forcing a complete app recompile just to change that one tiny value. It means your exact same build is going to behave differently depending on where it's running. And we all know dev staging and prod are absolutely going to require different base URLs, different timeout links, and different auth details. Anything that changes based on the environment belongs way outside your compiled Java code. The fix? We extract them out to your application.properties file or environment variables. Basically, separating your config from your code is just non-negotiable for a production-ready app.
All right, part 2, setting up application properties.
Let's actually look at the code and establish these properties. So, in our application.properties file, we're not leaving anything out. First up, we set spring.application.name equals RestClient. That just gives our app a proper identity. Then, we group our custom properties under a nice logical prefix, so we use JSON placeholder. We define JSON placeholder.base-URL equals https:// JSON-placeholder.typeofcode.com. Right under that, we've got JSON placeholder.connect-timeout equals 5s, followed by JSON placeholder.read-timeout equals 10s, and finally, JSON placeholder.client-name equals RestClient-demo. By setting it up exactly like this, we've basically pulled all those moving parts completely out of our Java code. Now they live in a dedicated config file, making them super easy to swap out depending on the environment. Moving on to part 3, the magic of duration. Now, you might have caught something a little interesting about how we just wrote those timeout values. We used 5s and 10s instead of typical integers like 5,000 or 10,000. And I really want to pause on this because it trips up a lot of developers. Remember, a properties file is just text. It only ever holds strings. So to that file, it's literally just the string 5s. But our application doesn't want a string. It actually needs a java.time.duration object to handle those timeouts correctly. Well, this is where Spring Boot steps in and works its magic behind the scenes. When Spring sees that your target field is a duration object, it just automatically reads those human-friendly suffixes. 5s for 5 seconds, 500 ms for 500 milliseconds, or even 2m for 2 minutes. It parses that string and converts it straight into a java.time.duration object for you. It hands you the exact right object, and you didn't have to write a single line of manual parsing code. It's clean, it makes the config super readable, and it literally eliminates an entire category of conversion bugs. Okay, part 4, binding to typed records. So we've got our properties defined, and we know how the conversion magic works. Now we need to give those properties a safe, permanent home in our Java code. We're going to bind them to a neat little typed record. Let's walk through this code together. Up at the top, we drop in the @ConfigurationProperties annotation and pass it the string JSON placeholder. That tells Spring, hey, look for any properties that start with this prefix. Then, we declare public record JSON placeholder properties, and inside those parentheses, we define the fields so they perfectly match our properties: string base URL, duration connect timeout, duration read timeout, and string client name. By using a Java record paired with this annotation, the rest of your app gets compile time-safe access to these values. No more relying on those flimsy, stringly typed lookups that just blow up at runtime if you happen to make a typo. Which brings us to part 5, enabling configuration scanning. So we've got the properties file, we've got the record, but there is one final wiring step to get the whole thing actually working. And honestly, it's the one developers forget the most. Let's talk about the component scan blind spot. You see, a class that only has the @ConfigurationProperties annotation doesn't actually get picked up by Spring's standard component scan. That default scan is really only looking for standard stereotypes, like @component or @service. So because our record is just a configuration property, Spring just ignores it by default. The result? If you try to run your app right now, it simply won't start. The REST client bean we eventually want to build relies on this record, and without the scan picking it up, there's no bean to inject. Talk about a frustrating error if you don't know what's going on. But the fix is super easy. To get rid of this blind spot and explicitly tell Spring Boot to go find these records, we just add one simple line to our main class. If we look at the code for RestClient application.java, you'll see our standard @Spring Boot application annotation at the very top. Right beneath that, we just pop in @ConfigurationProperties scan. Then we've got the standard public class RestClient application, and inside our public static void main method, passing in the string array of args, which then calls Spring application.run, passing in RestClient application.class and args. That @ConfigurationProperties scan annotation right there, that is the magic key. Leave it off, your app crashes on startup. Add it, and Spring perfectly registers your configuration record as an injectable bean. It's that simple.
And finally, Part 6, Summary and Next Steps.
Let's do a quick wrap-up of this explainer and review the architectural flow we just built, just to make sure it's really cemented in your mind. To summarize our wiring, Step 1, we defined our environment-specific values over in application.properties. Step 2, we used the @ConfigurationProperties annotation on our Java record to safely bind those values and automatically type convert those text strings into duration objects. Step 3, we used @ConfigurationProperties scan on our main class, so Spring actually finds the record and registers it as a bean. And Step 4, all of that allows our properties to be cleanly constructor injected into our REST client configuration. We literally completely decoupled our config from our code logic, which is exactly how you want to build resilient software.
So now that you know how to securely and elegantly manage your properties in Spring Boot, we actually need to use them. Make sure you check out the detailed article link in the description below so you can review all the code we went over today. And definitely join me in the next part, building the REST client bean plus timeouts, where we are going to put all these properties to work. How much cleaner is your client code going to look when you aren't hard coding all those strings? Stick around and let's find out.